for this next part, you will need Desmos test mode for your test, which looks like this when you sign into it. And we are going to be doing the regressions here, and I'm going to have to kind of keep this, zoomed out, unfortunately. But here it has the chart below gives the height and weight of random students in a high school. So here are the heights and here are the weights. And it asks you if it is linear or if it is quadratic. Just so you know how to tell whether it's linear or quadratic, there's a couple ways. One way is if you look at the numbers, like in terms of increasing and decreasing, you should see that like either the numbers are usually kind of increasing or decreasing versus a quadratic, which is a U shape. In a U shape, that means the values would like go down and then up, or they'd go up and then down. That would be a quadratic. But linear, they're either like going to go up at a slant or down at a slant. So in order to get a table on Desmos, you have to press this plus sign and go to table, and you can just enter in everything, which I'll do now. 66, 62, 71, 64, 75, 70, 64, 71, 69, 68. And hopefully I typed in everything correctly. Always double check, because you never know. Okay, Y values is 147, 124, 189, 141, 172, 144, 112, 165, 129, and 177. And none of these points are showing up here because it's not zoomed correctly. The easiest way to zoom is to press the zoom button, which is right here, that little thing, and boop, and it shows up like that. So you look at it and, does it look like a U going down or a U going up, or does it look like a line? Well, in this one, you can see that they are mostly going up. You don't really see it go back down again, so this is not going to be a quadratic. In a quadratic, it would either start going down or it'd be going up over here. If you kind of zoom out, you can see that it's starting to look a little more linear, kind of like that. So this is going to be linear. So over here on the sheet, I'm going to write down linear. And that says, what is the best estimate for someone who is 60 inches tall, which just means that later on we're going to say X is 60. That'll come in after we do our regressions. Since this is linear, we have to use the regression on Desmos, which is y1 tilde ax1 plus b. So you have to know that and plug it in. So just to show you y1, all you have to do is press y1. It automatically will do that down thing. Shift over here will get you that tilde. And I'm just going to show you one thing real quick. If I do ax plus b, I want you to notice that, I'm sorry, I'm supposed to do an ax, boom. Notice that nothing shows up when I do this. It has a little triangle saying error. I'm purposely doing it wrong right now to show you what happens if you forget the little ones, because that is going to be the most often missed thing. You have to have y1 and x1. If you only do one, it's not going to work. So if during the test you're seeing this little sign, just remind yourself, well, maybe I forgot a 1. And sure enough, if I press 1 right here, it's going to work out. So there you go. So over here, it's going to tell you what A and B are. So I'm just going to round to one decimal place. A is equal to 4.4. And B is equal to, oh boy, negative 148.9. There we go. So these are the numbers it gives me. This is the number the question asked for. And this is all being compared to y equals ax plus b. You're used to it being mx plus b, like that, which is fine. Just know that the first number is 4.4. So when you do this, y equals the first number, which is 4.4 times 60, because that's x, plus minus 148.9, like so. So you plug in the A, you plug in the B, you plug in the X, which was 60. And you just go here, 4.4 times 60 minus 148.9. And it's 115.1 pounds. There you go. Okay, there we go. Well, we're about 5.5 minutes into this, and we just have the back to go. So I'll see you then.